Salomon, named after its founder George Salomon, produced ski boots right at the heart of the action in Annecy, located in the French Alps. They specialise in creating custom moulded and fitted ski boots and take great pride in providing athletes with these bespoke bits of kit that will help skiers tear up the snow.
At Salomon, we've been making boots since almost 40 years. The company was founded in 1947. In 1979, Salomon introduced the first alpine boot, which was a rear entry boot, quite revolutionary at that time on the market.
The production of a Salomon ski boot begins with market research that will help determine the customer's needs. This is conducted in the form of focus groups with various countries, dealers and athletes in order to determine the needs of each individual skier. This stage will reveal whether a particular boot should focus on being lightweight amongst other needs.
Here in the Annecy Design Center, we have the capability to start from scratch a new concept, which means to start from the market research and to go until a final product dedicated to the end consumer.
The correct last for the boot then must be defined. A last is essentially the foot shape that the whole boot is moulded around. Using this fancy bit of kit, a foot scan is taken off the athlete, and then all of the information recorded in the scan is uploaded to a database that can work out exactly the size and shape of the last that is required for each boot design.
In parallel, we're going to work on how do we create the new features and the new innovation. So we are working on the existing plastic parts, and we're going to try to rebuild a new boot with existing parts.
Next is the design creation stage. Using the defined last, a designer gets to work drawing out the boot's features and lines. They use mock-ups and trend boards for inspiration in order to best combine functionality with style. Using these designs, prototypes can then be created with old plastic components and handmade models. This stage is vital as it gives the designers a chance to transform their ideas and see them come to life. The prototypes allow them to evaluate the feasibility of each of their innovations.
As soon as we have some prototypes ready, we're going to go on snow to test them, to see if they are working well on the snow, which is at the end what we are looking for, and to make sure that, again, the innovation we want to bring is working on the field.
Once they are happy with their prototypes, the production of their new boot can really begin. Armed with the information from the design stage, moulds are created so that all of the plastic parts of the boot can be injection moulded. Injection moulding essentially forces melted plastic into a mould in order to accurately and consistently produce plastic parts. The shells of the boots are made using this injection moulding technique, as well as the cuff of the boot and even the sole. With the plastic parts complete, it is time for the liner of the boot to be created. The liner is there for comfort and to wrap the foot and hold it securely in place. This liner acts as a cushion from the shell, protecting feet from the cold in the meantime. The liner is built up in what is known as the soft pilot area, which is where all of the soft parts of the boot are worked on. The liner itself is composed of more than 230 pieces of foam, leather and textile. As well as providing comfort, this liner also plays an important part in the performance of the ski boot. It works closely with the plastic cuff of the boot to give just the right amount of flex for the user. Once the liner is complete, our boots are very nearly ready to hit the slopes. All that needs to be done now is to take these shiny new boots through their thorough testing procedure. In the testing lab, the boots are placed in a cold room that is set at the chilly temperature of -18 degrees centigrade. To put it into perspective, that's the temperature of your home freezer. In this cold room, the boots are put through their paces and tested for durability, breakage tolerance, and a whole host of other performance tests.
So we're going to have some machines that will reproduce a lifetime cycle. Like, for example, we're going to put a boot doing 35,000 cycles, which is something comparable to 5 years of use in normal conditions, to see if the rivets are good enough, if everything is good enough for 5 years.
And with the tests all passed, our boots are ready to be put into action on some of the world's biggest slopes and mountains. Snow boots, truly a wicked invention.